Hello everyone, let's solve the problem B from the weekly contest 381. Count the number of houses at certain distance 1. First, let's understand the problem. You are given three positive integers n, x and y. In a city, there exists house numbered 1 to n connected by n streets. There is a street connecting the house numbered I with the house numbered I plus 1. So it's saying that we have n streets which are 1 to n which are connected by n streets, and I with I plus 1 is connected. So if you have 1, 2, 3 and 4 as my houses, 1 and 2 is connected, 2 and 3 is connected, 3 and 4 is connected. For each k, an additional street connects the house number x with the house number y, and is saying that there will be another integer x and y. So you will give x and y. If x is 2 and 4, so there is one more edge between 2 and 4. Now for each k, such that you need to find the number of pair of houses, house 1 and house 2, such that the minimum number of streets that need to be traveled to reach house 2 from house 1. Suppose I want to reach 4 from house number 1. How many steps you are going to make? 1, 2, 3. If you are going this way, but if I want to, I can use this path as well, right? To reach 1 to 4, I will go 1 to 2 and 2 to 4 in 2 steps, right? So he won the minimum number of streets. Minimum number of streets. We need to return a one indexed array result of length n, where result of k represent the total number of pairs of houses, such that minimum streets required to reach one house from the other is k. And he's saying that we should reach every house, and we want every distance, and we want every distance. That means suppose if you see this example, so here again 1, 2, 3, and 1 and 3 is connected with this edge. Now let's see how many distances I will get. 1, 2 and 3. So I need to return the array size should be n. So one distance 1 to 2, 1, 2 and 3, and the reverse, So total there are 6. For two distance there is no edge, right? Suppose there is an edge between 2 and 3, then from 1 to 3 we can go in 2 steps, but here everything is going in 1 step. And here you are given that note that x and y can be equal, so it can be mapped to 3, or it can be mapped to 2, or it can be mapped to 1. So let's after seeing this type of problems, first thought we will get is sh- shortest distance, all path shortest distance. So if you see here, if you are like familiar with graphs, you know about Floyd Warshall algorithm, right? So if you don't know about that, you can come to Geek for Geeks and you can read about this Floyd Warshall. So it will give all path, all distance, shortest path algorithm. From every node it will check. So suppose we have nodes like 1 is connected to 2, 3 and 4. 2, 3 is connected to 4 and 5. It will check from 1 to 5 how much my minimum distance, then 1 to 4. And suppose my 1 to 4 is directly connected somehow 1 to 4 is directly connected. From here it is 2. If it is directly connected, it is 1, so it will take you 1. So how this is implemented, let's see with this example. Let's say this example, n is equals to 5. N is equals to 5. So we have 1, 2, 3, 4 and 5, and you have given x and y as 2 and 4. X is equals to 2, y is equals to 4. That means 1 to 2 my length is 1. So 1 to 2 my length is 1, and 1 to 2 my length is 1. I will fill this matrix. I will make n into n cross n matrix, and then I will fill 1 to 2, and 2 to 3 also it is 1. 2 to 3 is 1. 3 to 2 as well 1. 3 to 2 1. 3 to 4 and 4 to 5, these are all are 1. And from 2 to 4, so if you are going 2 to 4, if you see here 2 to 4, it's also 1. 2 to 4 or 4 to 2, which is 1. Now, now what Floyd Warshall will say shortest path between all pairs. So here it will the algorithm states that if you take the intermediate vertex k and my start is I, my destination is j. If I want to reach I to j, then minimum of v of I j. First I will go to I to my intermediate vertex, then from intermediate vertex to j, v of ik plus v of kj. Let's see for 2, if I am taking 2 as my intermediate vertex, 2 as my intermediate vertex, if I want to reach from 1 to 4, if I want to reach from 1 to 4, 1 to 4. So first I will reach 1 to 2, then 2 to 4. That means from 1 to v 1 to 2, I will calculate the distance. From 2 to 4, I will calculate the distance. From 1 to 2, I have 1 to 2, which is 1, plus 2 to 4, which is 1, which is my answer is 2. So in this way, I will calculate the minimum. So you can go like this. You can also go 1 to 2 and 2 to 4, or if my intermediate is 3, I can go to 1 to 3 or 3 to 4. In this way, I will take my intermediate vertex, and I will calculate for every node, for every node. I think you have got it, so you can watch that algorithm as well. Now let's see the coding part. Now we are filling for I and j plus 1, n plus 1, n plus 1, and for every node, for we are iterating, and for I and I plus 1 there is an edge j and j plus 1. So j and j plus 1 equals to 1, and j plus 1 to j also there is an edge, we are making 1, and x to y and y to x, it we have ones. Now this is the shortest path. K is my intermediate vertex, and I and j my start node and my destination. This is my intermediate. So if I want to go to I to j, first I will go to I to k, which is my intermediate, then k to j. In this way I will calculate the minimum, and this is my result. This is my result. In result we have total n, 1 distance, 2 distance, 3 distance, till n minus 1 distances. Sorry, n distances. And here we are calculating the value, and value minus 1 plus plus, because our result will start with index 0. That's why we are making value minus 1 plus plus, and we are returning the result. So here my time complexity will be order of n cube, and we are using extra space, so it will be order of n square. We are using n into n grid. So I think you have got it. So if you couldn't able to understand, so please watch Floyd Warshall, or I will be really sorry for that if I couldn't able to help you. So if you understood it, please do like, and if you are new to the channel, please consider to subscribe. And I have created a WhatsApp community, Code with Confidence. If you are interested, you can join there. There we will discuss all the LeetCode problems and data structures and algorithm problems there. So I'll see you in the next video. Bye.